use for the focal functions. So what is important in focal functions, you have to define the focus. What is the area you are going to cover as the focus? So you need to, if it is 3 by 3, you can have a 3 by 3 focal function. You can have 4 by 4 or 5 by 5, depending on the kind of smoothing you want. You can have it, because when you put the focal values, what you get is, especially if you want to have a smoothing function, focal average, you smooth it. If you want to enhance something, you look at it different way. So you can have different functions, sizes of the thing. If you look at remote sensing, you use different filters on raster images. So raster images is like a raster layer in the GIS, and then you can apply these filters. We call different types of filters edge enhancement filters, which can enhance the edges, and you have smoothing filters, low pass filters, high pass filters. There are different types of filters you use in remote sensing to get certain focus extracted from the data. But GIS, we use this to get data layers, either smoothen, enhance the edge, get the values of the range, and so many functions. And third type of function that we are looking at is zonal function. So we look at two types already, local and focal. The unique feature in the focal function, which you look at before, it uses the cells in the neighborhood. And when you look at the neighborhood, you can, in GIS, you can define the neighborhood function in two ways. Neighborhood function in two ways. One is a neighbor who is sharing a non-zero boundary with you. Like if you are a cell, if you are in a particular cell, and a neighbor is defined as another cell which shares a non-zero boundary with the particular cell that you are looking at. Right? I'm still talking about the focal functions, not zonal. Right. So when you look at a neighbor, a definition is it is sharing a non-zero length boundary with the particular cell. So if you have that definition, a neighbor is defined as another cell which shares a non-zero length boundary of that cell under reference. How many neighbors you can have for a particular cell in a raster layer? Or in a raster cell, how many non-zero length boundaries you have shared with the other cells? Anybody?
So 4 boundaries.
Yeah, you have 4, because you have cell in the north. Like if you look at this, if you take, for example, the cell with the number 3, you have a north cell, you have western cell, you have eastern cell, you have southern cell. So these 4 shares non-zero length boundary with you. So there are 4 neighbors according to that definition. And when you talk about a neighbor, it is, I already told you, it is non-zero length boundary sharing cells. So there are 4 cells. And we call this as a 4-way connectivity. 4-way connectivity. Like, for example, for this cell with the number 3, it is connected with the cell in the north side, cell with the east side, west side, and south side. So the connectivity is 4-way connectivity, north, south, east, west connectivity. But if you look at this particular cell, uh, if you look at this particular cell, uh, you can consider this cell, although it doesn't share a long boundary, but it is adjoining. Like from this cell, you can just cross this and enter to this cell without going through the cell 2 or 0. This, without going through these 2 cells, from this cell you can enter here. And same with here. Same with this cell, same with cell. So now there are 8 cells which are connected together with the cell with number 3. So 8 plus 1, there are 9 cells, right? So this, if you are looking at the all neighbors, even with 0 length bound, because this cell, if you take, is sharing no boundary with this, but it is adjoining. So it is called 8-way. You have 8 cells around, 8-way connectivity. You have 4-way connectivity, you have 8-way connectivity. So whenever you talk about raster neighborhood, you have to define which connectivity you are using. Whether you are using 4-way connectivity or 8-way connectivity. Okay. Now, if you look at the distance from, now if you look at the cell number with the number 3, your distance from cell 0 in the north to the cell number 3 is considered from the center of that point to the center of the other cell point. So your distance is calculated from center to center. Okay. So if the resolution of the raster is say 100 meters, you have a 100-meter resolution raster, and then from the cell with north cell 0 to the cell with number 3, what is the distance? If the resolution is 100 meters. Anybody? If the resolution of the raster is 100 meters, that means each cell is 100-meter long, width and 100-meter height. So this both sides, it is 100 by 100. So from this cell to this cell, what is the distance? Accepting that you measure the distance from center of the cell to the center of the other cell. That is how we get the distances. So what is the distance?
100 meters.
It is 100 meters, because if you look at the center of the cell to the boundary, it is 50 meters, half of the cell size. And then from the boundary to the next center, it is 50 meters. So 50 plus 50, 100 meters. So from here to here, the distance is same as the raster resolution, 100 meters. But if you define the 8-way connectivity from this cell to this center. From this center straight to this center. It is not 100 meters. Although from this center to this boundary 100 meters, from this cell to this boundary 100 meters, from this cell to the edge of this is not 100 meters. What is the distance? Okay, if you assume that not 100, 1, right? 1 meter resolution. So center to the boundary is 1. If you use the Pythagorean theorem, right? You have a triangle now, both sides 1 and 1. So 1 squared plus 1 squared square root. That is square root of 2, right? 1 square is 1 plus 1 square is 1. And so 1 plus 1 is 2. And so 1 squared plus 1 squared, square root of everything. So that is square root of 2. So from here to here, the distance is not 1, square root of 2. Okay. From here to here, center, again square root of 2. All right. So what is the total distance? Two square root of 2, right? From here to here, distance is 2 into square root of 2. Okay. Now, if this is 1 and this is 1, right? If it is 0.5, if it is half, we have to calculate accordingly, right? I assume that halfway is 1. Okay. I don't know whether you got confused. So I assume that this has a 2 by 2, halfway it is 1 and 1. So then it is 2 square root of 2. From here to here, it is 2. From here to here, it is 2. Now you get 2 into square root of 2. Square root of 2 is somewhere around 1.4. So it's little more than 2. 2 into 1.4. Right? 2.8. If the distance here is from this cell to this cell 2, from the center of this cell to this cell, it is 2.8. This is how we calculate the distances. Any doubts about it? Right. If the cell size is 10 meter by 10 meter, if the cell size is 10 meter by 10 meter, right? What is the distance from this cell to the cell with number 3? If it is 10 meter by 10 meter resolution, what is the distance that you have from this cell to this cell with number 3? Can you calculate and drop me a message through chat? Okay, most of you got the right answer. It is 4.14.14. So you know how to calculate because that is important when it comes to the next step. So remember the four-way connectivity or eight-way connectivity. Four-way connectivity, you consider only non-zero length boundary. Having a non-zero length boundary is four-way connectivity is basis. Eight cells, eight-way connectivity, you use all the neighbors irrespective of the length of the sharing boundary. Even if you share zero length, but if it is in the next round. So that is how, by using eight-way connectivity, you define 3 by 3 area, or we call it 3 by 3 kernel. Right. When you go to the boundary, you cannot find all 3 by 3 area, because if you take this particular cell, first cell, you don't have 3 by 3 area because uh, you don't have 8 cells around. You have only 3 cells. You have, this is a neighbor, this is a neighbor, and this is a neighbor. You have only 3. So even though you take eight-way connectivity, boundary cells may not find sufficient neighbors to calculate the eight-way connectivity cells. But what you do is you take whatever the available area. Although you don't have all 8 cells in the surrounding, you use whatever the cells you have in the surrounding, whatever the available cells, to calculate the values. Now, if this is like you have a 4 by 4 raster here, this is a 4 by 4 raster. How many complete eight-way connectivities you have for this 4 by 4 raster? How many complete eight-way connectivities you have for this raster? Can you drop a chat message? Okay, good. Most of you have got the answer right. You got 4 complete, because only these 4 cells, you will have a complete eight-way connectivity cells. But when you have a large raster with thousands of cells, you would find that only the boundary cells will not have eight-way connectivity. All the other cells will get eight-way connectivity. Right? You get the point. Only the boundary, sorry, only the boundary cells, you will not have the eight-way connectivity, but all the inner cells will find the eight-way connectivity. So when you have a 1000 by 1000 raster, right? 1000 by 1000 raster, you will only have 1000 by 1000 raster is 1 million cells. Out of 1 million, you will find not having a complete eight-way connectivity is only 3,998 cells. Right? So when you have the 1000 by 1000 cells, so you have altogether 1 million cells. Out of the 1 million cells, you will only have 3,998 cells without having the complete 8-way connectivity neighborhood. If you look at this 4x4 raster, 4x4 raster, you have 16 cells. So you have uh, 4 cells with 8-way connectivity. All other 12 cells, you will not have the connectivity. That's how it goes. That knowledge is important when you go alone. So now you look at some of these focal sums. Focal mean, we look at this before. So now we go to the zonal functions. Now, not like focal functions where we define like 8 neighborhood cells as the focal area. We define a focal area by having 8 cells, 8-way connectivity. Zonal function, you don't need to be a neighbor. You don't need to be a neighbor to define a zone. But focal function, you had to have a neighbor. It has to be connected, either 4-way or 8-way connected to be a focal point. But here, zonal functions, it processes the data of a grid in such a way that cells of the same zone are analyzed as a group. So here we analyze cells of the same zone. It doesn't matter where it is located, whether it is a neighborhood or not. It's considered as the same zone. So typical zonal function requires 2 grids. One is zone grid, which defines the size, shape, and the location of each zone. The value grid, which is to be processed for analysis. So the objective of this function is to identify the zonal values so that we can get an idea about the zone. Right? Now, I'll give you an example. For example, if we look at the dry zone, earlier we defined the wet zone, dry zone, and the arid zone. Now we don't call it as arid zone. But earlier we call it that area as arid zone. One is in this Mela, other one is in Hambantota. Right? We identified 2, but these 2 are located at 2 different zones, areas, but it's the same zone. Right? So when you look at the characteristics, if you are asked to calculate the average rainfall of the arid zone, you take the data from not only from the MENA area, but you take the data from some further down, Hambantara data also. And then you get the value calculated for that zone, irrespective of the where the zone is located. So it is different to the previous 2 functions, because previous 2 functions, first one we look at individual cells, we process individual cells without looking at any of the neighborhood. Second one, focal functions, we look at the immediate neighborhood, 4 cells connectivity or 8 cell connectivity. We define the neighbor who is at the adjoining cell. A neighbor is at the adjoining cell. But zonal function doesn't look at whether it is adjoining or not. It looks at whether it is the same zone. Right? We'll look at the example. we are looking at zonal max function. We use is a zonal max. You have a zone grid. First one is a zone grid. The second grid is a value grid. First one is a zone grid. That means it identifies zones. Okay. It identifies zones. Now, if you look at the zone 1, it's located at two places. One is here, one is here, that is one zone, and again another zone of number 1 here. So both are the same zone, located vastly different places. If you look at the zone 2, so you have zone 2 here and the zone 2 here. So these two are separated by others. So zone 3 is in the middle, only one zone. So if it is adjoining, it is same zone, right? Same zone. If it is not adjoining, it is same zone, but you identify it separately as two parts. Like if you ask how many zones, zone 1 areas you have two zone 1 areas. How many zone 2 areas? We have two zone 2 areas. How many zone 3 areas? We have only one zone 3 area. That's how you look at it. So that is the zone grid. And this one is the value grid. These are the values of each cell. We don't look at the zone here, we look at the value. Now, when you ask the function to calculate zonal maximum, right, zonal max, you can use zonal min, zonal minimum. You can even look at zonal standard deviation, zonal variance, whatever the statistical parameters you can use. So zonal max means first you look at the zone 1. These 5 cells, sorry, these 5 cells, here 3 cells, here 2 cells, all 5 are in zone 1. So what we are asking is all these 5 cells which are in the zone 1, what is the maximum value? So if you look at here, out of these 3 cells, maximum value is 8. Out of these cells, maximum is 5. So altogether, zonal maximum is 8. So you put 8 for entire zone. Sorry. Right? Same with the zone 2. You have 3 cells. So what is the highest value in the 3 cells? Sorry. 5. Right? These 2 cells, again 5. So you put 5 in the output, all 5 cells. And zone 3, your highest value is 7. So you put 7 value for the entire zone. This is the zonal max output from this value grid with respect to the zonal grid that you define here. Is it clear? Right. If you have understood this correctly, can you calculate zonal min? Zonal min and produce, just put the values. You don't need to draw the grid. Just put the values on 4 lines and send it to chat. Zonal min, zonal minimum function. If you're not sure, just ask me. Well, you got different answers from different, so some answers are not correct actually. Okay, let us look at the zone 1. What is the minimum value in zone 1? What is the minimum value in zone 1? Anybody?
3.
3. So zone 1, all the area should be filled with value 3. Right? Some people have only 1 and 2s, not 3. Right? So all these 5 cells in the zonal min function, you should have value 3. Okay. Then zone 2,
1.
you have zone 2, your highest minimum value. What is the minimum value in zone 2?
1.
1. So minimum value. So all the 5 cells in the zone 2 should be filled with 1. So zone 1, every cell filled with value 3. Zone 2, all the cells filled with value 3. Sorry, value 1. And zone 3, you have only 3 cells. What is the highest value? This is the lowest value.
2.
Zonal mean 2. So all 3 areas should be filled with value 2. So you have the new layer having values 1 to 3, uh, zone 1 having value 3, zone 2 having value 1, zone 3 having value 2. Okay? Any doubts? Right. Since some of you got it wrong, can you try now zonal, not max, not min, zonal range? Zonal range, and just uh, send me through chat what is the zone 1, what is the range value, zone 2, what is the range value, zone 3, what is the range value. I'll give you a minute. Um, Javardhana and Ratnayaka. That is not the way to put the range. Range is maximum value minus minimum value. That is a range. Otherwise, you cannot have a value. No? You have two values. So range is maximum minus minimum. So your answer, the way you look at is right, but so zone 1 range is 5, zone 2 range is 4, zone 3 range is 5. So if you ask the zonal standard deviation, what you need to do is you get the all zonal values, calculate the average, subtract from the average, square it, sum it up, and then divide by the total number and get the square root of it. That is the standard deviation. So you need to do all that calculation if you ask the standard deviation of the zone. Okay. So that's how some of your answers are not correct. For example, Vaninayaka's answer is given the range. So that's not the range. Range is the one value, maximum and minimum. Maximum subtracted minimum. Samaravira is not correct. Nishanka is correct. Mm, Bimsara is correct. So now, if you look at the values, if you look at the zonal range, now your values are only 4s and 5s, right? Your values are 4s and 5s. So earlier we had the values in the range of 1 to 8. Now we have only two classes, 4 and 5. So when you do the range, what happens is whether it is 5 minus 1 or 6 minus 2 or 7 minus 3 or 8 minus 4, doesn't matter. It belongs the same. So what does the range give you? What does the range give you? As the name says, it gives you the distribution of values, how the values are distributed, whether the values are distributed in a narrow range or whether the values are distributed in a large range. So if the value is high, zonal range, that shows that particular zone is highly heterogeneous. If the value, zonal range value is low, it means wherever it is located, the values are more or less homogeneous. Right? So when you analyze the spatial data, you can say when you have a narrow range of values for the zonal range, you give those areas as more or less um, homogeneous zones compared to the zones which are having very high values, which are called heterogeneous zones. Right? So we define, depending on the range of values, heterogeneous zones and the homogeneous zones. The zone can be located in different places, but if the same zone, you can see the difference. Any questions? Any questions from what we discussed so far before we move into the other function?
Sir, can you explain again how can we get range?
Range is from, if you look at the zone 1, right, we are defining zonal range. Okay, zonal range. Now, so we look at first the values of the zone 1, right? Values of the zone 1. So what we look at is like the values of the zone 1. So this is a cell, this is a cell, this is a cell we are looking at, and this and this. Okay, we are so looking at zone 1. So range means we'll need to look at the maximum value in this zone. What is the maximum value? 8. And we look at the minimum value. Minimum value is 3. So the range is from, the values are there in this zone from 3 to 8. So maximum is 8, minus 3 is range is 5. You have 5, all the values are distributed of range of 5. Okay. If you look
Okay.
at the zone uh, 2, this is zone 2, right? This is zone 2. 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 So when you look at these values, you look at minimum is 1 here, and minimum is 1, and maximum in the zone is 5. So the range is 5 minus 1, 4. If you look at the zone 3, zone 3 is here, this cell, this cell, this, and this cell. So Maximum is 7, minimum is 2, range is 5. So you put 5 for that range. That's how you produce the output. So all the cells of that zone, you give the same value. If it is zone 3, value is 5, all 3 cells you put the value 5 in the output grid. Okay? Any doubts?
No, sir.
Right, okay. Right. Now we go the last one. We look at local function, focal function, zonal function. Now we go to global function. Right? Global function. See the difference. Output value of each cell is a function of the entire grid. Right? Output value of each cell is a function of the entire grid. Now look at the source grid where we have two types of cells. Number one cell, other one is number two. Three cells of number one cell of number two. This is called source grid. Right? This is called source grid. Now, what your function is Euclidean distance. We learn what Euclidean distance is. Right? It is the aerial distance. Right? What is the other distance we learn? We learn some other distances.
Manhattan distance.
Manhattan distance. Very good. So now here we are looking at Euclidean distance. Okay. Now how do you get this output grid? All right. Now what we do is assume that source grid is a water source. So there are three cells. Say for example, it's a large lake or something. Only one cell with number 2, that is a well. That's a well, right? Now, looking at each and every grid, you want to compute Euclidean distance to that particular cell. Okay. So, Euclidean distance, not like Manhattan distance, you can travel northeast, southwest. In addition, northeast, southeast, southwest, and northwest directions. So you can move at 8 directions, right? So that you can define the nearest, shortest distance from one point to another, aerial distance. So you can right. Now take this cell. Can you see that cell where I am referring to?
Yes, sir.
Right. Now, if you want to calculate the Euclidean distance for that cell, that means from that cell to travel to the source grid cell, because the people in this cell need water. So if they have to get water, what is the nearest source and what is the distance to that source? So if this cell, people in the cell, assume in the center to the boundary of that is What is the distance? 0.5. This 0.5 from here to the center of that, another 0.5. So total distance is 1 to reach a water source. So you put 1 value 1 for that cell. Right? So people go to the nearest water source. Right? So what if we are putting is Euclidean distance to the nearest water source. Right. We'll take one more cell. This one. What is the distance it has to travel to reach a water source? If we shall move from the center to the boundary here, 0.5, from this boundary to this boundary, 1, this to the middle of that 0.5. So total distance is 0.5, 1, 0.5, that is 2. Now, somebody can say, why don't you go to this? Right. So to go there, you need to go either this way and here, or you need to go across the sill to here and here. Right. So from here to here, middle, the distance is 1. From here to here, the distance is, what is the distance? Square root of 2, right? So 1 plus square root of 2 is more than 2, right? Therefore, it is the Euclidean distance to this source is more than what you need to go for this cell. So therefore, we put the lower value there. Right. If you are here, which cell is closer to you? This one or this one? Source grid number 2 is closer because from here, you have only 1 unit distance here. From here to here, it is square root of 2. So square root of 2 is more than 1. Therefore, you take value 1 for that cell. Okay? Now, if you take this particular cell, from here, this cell to reach here, you go across and your distance is square root of 2. So 1.4 is square root of 2. Did you understand it or you have any doubts about the global function?
No, sir.
Right. Now, if you think of applications, what kind of applications you have for this? Now, for example, you are asking, right, what is the nearest school in terms of Euclidean distance to me? Right? What is the nearest school in terms of Euclidean distance? Now you have schools at various cells, right? And then you can look at your Euclidean distance and say, okay, this school is the school having the lowest Euclidean distance to you, right? This is the low. So when you look at the school, it is actually, if you want to calculate the distance, it is not the Euclidean distance because you are not flying, right? You have to go along the road. So what you have to take is on-road distance. On-road distance, not the aerial distance that you define in the Euclidean distance. Okay? But generally, because if you take the Euclidean distance, you make mistakes. When we were trying to establish new city universities, we said it should be close to the highway. So you look at the highway cells and identify the locations, and some locations are next to the highway. Euclidean distance is very small. But there's no point because although you are having a highway next to that land, you cannot enter the highway, right? You have to go to exit or entry point to enter. So what you need to do is in that analysis, not the highway distance, but the distance to the nearest entry point to the highway is should be the criteria. Right? You would have seen people advertise lands next to the highway. You have the land next to the highway, but there's no point. You need to go 10 kilometers to reach the entrance. Right? So when you define the functions, you have to be careful because you need to define functions properly, uh, having understood the situation. Same with the Euclidean distance. If you are flying, Euclidean distance is okay, but you can't fly, So you have to go along the road. Then we need to define on-road distance. On-road distance. In Manhattan area, in US, it is easy because it is Manhattan distance. Every property is connected to roads, and only if when you calculate the Manhattan distance, you can find the closest property that we are looking at. Okay, so if I give you a different source grid and different function, like can you calculate the output grid? Okay, assume the same source grid. Instead of Euclidean distance, use Manhattan distance. Use Manhattan distance and produce the output grid. How do you do it? Very easy. Okay, one thing I forgot. When you do produce the output grid, right, where you have the source grid, you put value 0 because when the source grid is assumed at the center, you don't need to travel any distance. Your included distance is 0 when you are at the source grid. So all the source grid values will be 0, right? That you need to understand. Okay. Now, if you ask to produce output grid by using Manhattan distance rather than Euclidean distance, it's very easy for you to find the distance. Your values where you have twos or ones, you don't need to change anything. Only where you have values of 1.4, you need to look at and change. So 1.4 is this cell, right? So this one. So from here, earlier with 1.4, now 1 plus 1, 2. So 1.4 becomes 2. All the other remain same when you look at the Manhattan distance. Very easy. So you make this 2, make this 2, make this 2, then you have produced the Manhattan distance. Any doubts? Any questions? Because Euclidean distance and Manhattan distance are same when you are located north, south, or east, west directions. Right? So all the cells north, east, west direction, east-west direction, east north-south direction, north-south direction. So all these cells, north-south direction, you don't need to change because it is the same. Euclidean distance and the Manhattan distance varies when you are not in the north-south or east-west lines. So from here, it is not the east, west, or north, south. So then you have to change that value. Now there are lots of applications of this. Right? When you have several places, now if you have a bus station, right? Now if you look at this, you need to take a highway bus, right? You are in Colombo. There are several highway bus stations. One is in Kottava, Makumuru, other one is Colombo, other one is Kadawatha. So where do I go? What is my nearest highway bus center? You can find from this. So when you have to decide where to go, which railway station I want to take the train, right? So whether I go to uh, like if you take the intercity train from Jaffna to Colombo, whether you go to KK station, whether you go to any other station or Jaffna station, you look at your distance. So distance, when we normally calculate, we couple it with the road distance. We take the road segments and connect it. But you can calculate the concept of calculating the distance like this. You get the minimum distance to the source. Your source is the railway station. Your source is the highway bus station. So to the source, what is the distance? That's how, whenever you ask the map about a choice, now what is the nearest restaurant? It calculates. It finds the restaurants around, calculate the distance and tell you this is the nearest one to you. And if you go to somewhere else and try ask the same question, it gives you a different option. So it is actually having a statistical basis when you calculate. Right? If you are going to get air travel, Euclidean distance is the right one because it can go to any direction. Euclidean distance means you can go to any place. And the aerial distance is the one which matters. Okay? Shall we look at an example?
Yes, sir.
Right. Now, travel cost for each cell is derived from distance to nearest source cell weighted by a cost function. Now, earlier case, we just had the distance function only. Source, we have source grid. We define the distance function, which is Euclidean distance. We get the output. Now here, we have one thing extra. We have a cost grid also. Right? Now I'll give you an example. If we want to construct a road, right? If we want to construct a road, the from say point A to point B, right? We want to construct a road from point A to point B, two places. Between that, we need to construct a road. Now, what is the shortest path between A and B? That is the Euclidean distance, right? Euclidean distance is the shortest path between wherever it is located, A or B, between A and B, shortest path is the Euclidean distance. There's no argument about it, right? Now, when we want to construct a road between A and B, we want to look at the cost also, right? We want to look at the cost. And also there are certain things which we cannot use for road. We cannot demolish. Say, for example, uh, you want to construct a road from, say, uh, Peradeniya to Digana, new road. So if you take the Euclidean distance, it goes through the tooth temple. So you can't destroy the tooth temple and make a road. That's not possible. So Euclidean distance is not possible all the time. We have restrictions. And your expenditure is high. For example, if you have to demolish large number of houses to put that road, your cost is very high. So normally when we define a travel path, not only the distance, we look at the cost also. Different land areas is having different costs. So this is what we define here in the cost grid. To go across that cell, how much it cost? How much it cost to go across that cell? Now, if we have the same source grid, in addition to we use the same Euclidean distance function, but in addition to that, we have a cost grid. Now look at the first cell here. Value is 2. When you just apply the Euclidean distance to the source grid, this value is 2. Basically, you have to travel from the source grid to the nearest source. From the point, you need to have Euclidean distance of 2. Now, if you look at the cost grid now, each cell travel across that cell, cost is different, right? Now, if you look at this cell like before, from here to here, what is the cost now? From here to here, if the cell from one end to the other end costs 2, halfway it costs 1. From here to here, it costs 2. So 1 plus 2 is 3. Not only there, you have to go to center of that cell. Then your cost is 4 divided by 2 is 2. 3 plus 2 is 5. So from here to go there, it costs you 5. Okay. I'll take the other example. From here, you can go Euclidean distance wise straight away to this, right? But from here to here, your cost is not only from here to here, it is 2. From here to here, 2 square root of 2, that is 2.8. From here to here, it is not 0.5, it is 0.7. So 2.8 plus 0.7 is 3.5. If you have any doubts, ask me how it was calculated. If you look at this cell, from here, your nearest source is this one. So you go straight. From here, center to this point, it is 1.5. From here to here, it is 1, 2.5. From here to here, 1.5. So 1.5 plus 2.5 is 4. Your value is 4. Right? So this is how you calculate it. Any doubts? Any questions? Now, depending on the cost grid, right? In this example, it won't happen, but depending on the cost grid now, your nearest source grid may be different. Now, from this cell, you went to the nearest cell, this one. But now, according to the cost grid, the output value or the nearest lowest cost would be to go to this source rather than going to here. Because if this cell, say you have, instead of value 2, you have a value of 50. You have a value of 50. So it is not worth going to that. It is worth going here and crossing it to this point. Right? So now your source where you target may be different depending on the cost. Depending on the cost. Right? So when we take a practical example, then only you realize how important these functions are. Any questions? Right. We'll take 2 minutes quick break. Have a glass of water, refresh yourself. 2 minutes we will start. Okay. Right. We'll continue. Now, without understanding this, how this works, it is impossible for you to understand the real world example. So, if you have any doubts about this, how the value is calculated, ask me now. Because if you don't understand this concept, you cannot, because when you go to real world example, it is much more complicated than this. So without understanding this part, you cannot imagine how you understand the concept in real world application. So you can see now when you ask the question, what is the path I want to go from here to there? What is the path? How many calculations are required? How the Google map makes the calculation. Right? The Google map, it is not raster when you take the roads. It's a vector-based system, but same like this, each segment is calculated separately. So whether it be raster or vector, your calculation procedures concept is same. Right. Okay. Before we go into the example, we just identify area numbering. All right. This is another concept which you already understood. Right. You remember we look at the four-way connectivity or four-cell connectivity, 8 cells connectivity. Now this is 4-cell connectivity. Right. If you have the input map, four-way connectivity map is this output map, which shows the areas, individual areas you have. I'll explain this way. Suppose 1 is water bodies, 0 is land. So where there is water, you number as 1. When there's land, no water, you number as 0. Right? So if there is water here in this particular cell, if this water is there here, if the water is here, is it the same water body or different water body? It's the same water body because this is all connected. So this, if you look at this, the entire area is one water body, right? So what we are trying to do is identify, because our grid structure doesn't look at the connectivity. So now we want to establish the connectivity. If this input map of water bodies are having the four-way connectivity, that is north, south, east, west connectivity, what be the number of water bodies you have in that area? That is the question. Because if you have the same reservoir or tank in the two adjoining cells, you don't call it as a two reservoirs, it's a one reservoir, right? So likewise, we are going to identify number of water bodies. So starting from here, four-way connected, not eight-way connectivity. From this water body, do you have any connectivity with the other cells? Here, no. Here, no. You cannot go anywhere. So this is isolated one. We call it as water body number 1. We go along. What is this cell? Is it water? No. This is not water. This is not water. This is not water. Then we go here and find water. So this is number 2. Earlier one, number 1. This is the second water body. Now this water body, we put number 2. We put number 2. And then we look at whether it is connected to any other cell. Yes, it is connected to this cell. So this should also be number 2. It is connected to this cell. So it should also be number 2. It's connected to this four-way connectivity. It is connected to this four-way connectivity. So all these 5 cells should be number 2. So we finish the first row. We go to the second row. Here it is a water body. It's not connected here because it's four-way connectivity. We connect it with this. Yes, it is connected. Is it connected with this? No, it is four-way connected. It's not connected, but it is connected with this. So these 3 are going to be water body 3. And then we continue. So we taken this. This is a new one. So we put number 4. There's no connectivity. This one we already took. This one we already took. And then these are all zeros. No water. This is water body 5. This is connected to this. 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 So all these 5 cells will have number 5. And then we go along. This is number 6. This is also connected. This is connected. This is connected. This is connected. So all this will be 6. There are 6 individual water bodies in that area. Okay. Any questions? Right. Now we go to a practical example. Right. If before we go into that, can we think of if it is 8-way connectivity, how many areas we will have? Now this is having 6 areas, right? 1, 2, 3, 4, 5, 6. 6 water bodies you have. If it is 8-way connectivity, what would be the total number of water bodies? Can you calculate and just put a chat message? Give you 2 minutes. If it is 8-way connectivity, what would be the number of water bodies? Can we put a message, chat message? I want everybody to answer. PWS. When you send the message, send it to me, not to everybody, right? So that the other people then start putting the same number and send. So number 3 is right. There are 3 areas if you go for 8 connectivity. Because if you look at this one, this area, this, and this all becomes 1. These cells becomes 2. And all the other, it's 6 and 5 areas becomes 3. That's how it goes, right? Okay. Now we go to the example. Example, right? A developer wants to estimate the cost of laying a pipeline across an area that includes residential, urban, commercial, and bedrock areas. The land cover grid file is shown in the following figure. Now, what's happening here? A developer, he wants to estimate the cost of laying a pipeline from one place to another place they want to put a pipeline. And when you put a pipeline from one place to another, the areas that you put the pipeline include residential areas, urban areas, commercial areas, and bedrock areas is open areas without any cover. The land cover grid file is shown in the following figure. So whether it's a residential, urban, commercial, bedrock is given in the land cover. Well, actually, it should be land, not cover, land use grid. Right, okay. This is the grid raster layer. First, you have row number and column number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so 10 by 10 areas. Your area is 10 by 10 cells, 100 cells, right? So you want to put the pipeline. And there are different numbers. These numbers refers to this. If it is 1, it's a transportation, it's a road or something. Number 3 is agricultural land. Number 5 is forest. Number 7 is water. Number 9 is residential. 11 is urban. 13 is commercial. 15 is bedrock. This is how the numbers are allocated so that we identify what it is. Okay. So if we go and look at the table now, we know what, when 1 is there, you know what it is. 3, 5, 7, 9, 13, 15, 11, 13, 15, we have values. So we know what what land you cover or land use actually you have there. Right? Now, when you have different land use, your acquisition becomes difficult because depending on the type of land use, your cost is going to be different. Right? Now, if you look at this grid and developer wants to put a pipeline from this 1 cell to 10 cell, from this cell, right? He want to put a pipeline from this cell, this one, to this one, right? 1 cell to 10 cell. He want to put a pipeline. Now, what is the cheapest path that you would recommend to him to put the pipeline? That is the question. So, the developer wants to put the pipeline across residential, urban, commercial, and bedrock areas. Now, he's asking what is the way to put the pipeline from 1 cell to 10 cell, right? 1 cell to 10 cell. Now, what are the options you have? You can say, okay, sorry, I made a mistake by putting this. This starting cell is this one, not this one. Okay, so I'll erase that. So first cell that you want to put is this one, right? From here you start, you go to this cell, right? So what are the options you have? You can simply say, okay, don't make big deal out of it. Just put the pipeline from here across this straight away, because your cell width and length are same in the raster, although you look different here. My drawing table is width and depth is same. So you just make a, a route and get the uh, distance directly, right? Like what we did before. You get the Euclidean distance from 1, 1 to 15, and then that is the path to put the pipeline. But then developer will find it is very costly. There are cheaper ways to put it, right? But if you ask the shortest path, that is the Euclidean distance. The developer is not asking the shortest pipeline because he doesn't need to ask anybody. If he knows that grid, he can just straight put the pipeline, right? If it is Euclidean distance, you just put it. It's not the Euclidean distance, but what is the least cost path? What is the minimum cost path that you can recommend to the developer to have the pipeline? That is the question we have in front of us. Now, I give you some more data. You don't have the cost now. You have only the land use coding, right? You don't have the cost function. What you have is basically the coding system. It doesn't show you the cost. Cost is different. This is the cost. If the land use is 1, cost is 10. If the land use is 3, cost is 20. If the land use is 5, cost is 30. If the land use is 7, cost is 40. All the other land uses 9, 11, 13 and 15 are costing 2000. So basically what he is saying is, I want to avoid 9, 11, 13 and 15 unless it is impossible to avoid because it's very costly, right? So if you take down these numbers, right? 1 is 10, 3 is 20, 5 is 30, 7 is 40. All the others from 9 to 15 are 2000. Right. Now, if you take down these numbers, now you will see if you go back to the previous slide, I'll allow you to write down these numbers. Now, what do you think? The cells where you have 9, 11, 13, 15, you want to avoid, right? You want to put the pipeline, avoiding right. Now, how do you propose? So I will help you by giving the next one. So this shows the cost grid, assigning cost to the each cell. Remember, we had the cost cell when we calculate the cost grid. Remember this cost grid? Right? We used to calculate the distances based on the cost grid. Now you have the same thing here. You have each cell. To put the pipeline across this cell, it costs this much. Now, what is the least cost path? What is the minimum cost path for the developer to put the pipeline from the cell 1, 1 to cell 10, 10. Right? I'll give you a few minutes to think. Can you identify the path from here? Give you 5 minutes to think. How do you put the pipeline? Can you draw the path of the pipeline? Okay. Um, what I do is you need to understand the functions that we define, starting with local function, focal function, zonal function, and then global function. Which function this is related to? Which function you want to use for this? Anybody? So definitely it's not local function because we are not looking at one cell and then calculate, because we are looking at the other cells as well. Not focal function because we are not looking at the only around 3 by 3 cell area. Not a zonal function, we don't define the zones as such. So it's a global function. That's a global function. And your how do we approach this problem from what you learn? Now, what one thing you would realize, although you learn the theory, when it comes to real world problems, solving real world problems is much, much complicated. When you learn the theory, it looks like, okay, I can do it. That's very simple. I can do that calculation. I know how to do it. But when it comes to a practical application, a realistic application, you find it extremely difficult to understand how you go ahead and make find the solution for that. Anybody has idea how what is the next what should be the next step, not the final answer. What is the least cost path for the pipeline? Now, what are the options you have? Where you can put the pipeline? Now, if you look at the beginning, you can put the pipeline across to reach here, right? That's one way. Or else you can put the pipeline from here, go straight to this, come down. That's also possible. Or you can put the pipeline, come down straight away, and then go to this point. That's also possible, right? And also you can go one cell here, come down, go another cell, come down, go another cell, come down. Likewise, also you can go. And you can go three cells here, three cells here, three cells down, three, yeah, different paths that is possible. So how do you really find out how you identify the least cost path to put the pipeline, considering the cost values in each cell? Or basically, avoiding these values of very high values, very high cost cells. How do you, to whatever the possible way, you need to avoid these values. But if it is unavoidable, you have no choice but put the pipeline across this. Right? And here, your connectivity. First question you have to answer, what is your connectivity? It is a not four-way connectivity. You can go across this eight-way connectivity. So from this cell, you can put the pipeline to this cell straight away rather than going through this, right? So that is. Now, to look at it in the general perspective, if you look at, now your idea is avoid very expensive land uses where you have value 2000 as much as possible, right? So you have here, if you look at this table, you have value 20, 20, 20, 10. which are surrounded by very high values. So if you are here, if you put the pipeline from here, somehow here, you have no way of coming here because it's all covered with very expensive, right? So you cannot put the pipeline using this area, right? And if you look at these cells, 30, 40 here, that's also surrounded by very expensive cells. So this is not the proper way of doing it. You need to do calculation. But if I think of roughly putting it, I have 8-way connectivity. So from here, either I can go here or here. No other way I can go. Right. So assume that I go here and come here. And if I go here and come here also, it is same cost. Right. And then my next option, I cannot go anywhere. I had to go this cell. So there's no point of coming to this cell. So from here, I come straight here, then I can go straight there. Or I can go straight to this cell. It is much cheaper. And then I can go to this cell and come here, but rather than going there, I can come straight to this cell. Okay. I'm just trying to show the quick path. And then I can move here. Then I can go here, avoiding, go here, and go here, move here. Because if I go here, I get surrounded by 2000. And then I can move here. So rather than going there and going there, I can go straight here, going there, and going there, can connect here, can connect there, can connect there, can connect there. There's no way I cannot avoid any of the 2000 cells here because 1010 cell is also 2000 and all the surrounding cells are 2000. So I had to cross it directly from here to here. That's one way of looking at it. But I may be wrong. There may be more cheaper parts than what I found. Right? What you need to do is look at this path, mark it on the sheet, just mark it. That is your tentative path. But there is a way to calculate. Now, if you look at the cost for each cell, right? Starting from here, put the pipeline to this cell, it costs 30. To put the pipeline to this cell, minimum it costs, so this is the minimum cost that would incur to put the pipeline. Right? This is the minimum cost. So when you put the pipeline, the minimum cost that you would incur is 3,316. But if you stop the pipeline 2 cells before, your cost is 296. So you are basically saving more than 3,000 if you stop the pipeline there. That's the suggestion you can make from this table. Don't put the pipeline up to that point. You can stop here. Your cost is much, much, much lesser than what you get at the end. But suppose developer wants to put the pipeline to 1010 point, you have no way of avoiding it. It will cost 3,316. Right? Now, you will see you can calculate these values from the previous table. If you take down that table, I'll give you time to take down if you have not completed it. Take down this table. Then from this table, you need to calculate the other table. In case if you have a doubt, right? If you have doubt, you can look at this table if you're not sure. But you don't need that table because since we have come into this is the actual cost. So you can take down this table. You can put this data, the format into a spreadsheet. You can put easily on a spreadsheet. I'll give you a minute to write it down. Use the global function method to calculate the value of the cost for each cell starting from row 1, column 1. So that cell should have value 0. To put the pipeline for that cell to that cell is 0 cost. But all the other cells we have a cost. You need to calculate it the way you use the global function. But that should be the minimum cost for each and every cell to put the pipeline. So if you have put the values down, if you have got the values, you will go to this table and you can write down this table, and then you need to identify the least cost path to put the pipeline from row 1, column 1 to row 10, column 10. So prepare this spread on a spreadsheet, identify the path. So put these data tables also on the spreadsheet, identify the least cost path to produce the pipeline using global function that we learned today. And then take this as an assignment and post it. You have 2 weeks by 12 noon next, not the next Sunday, the Sunday after the next. So that is 22nd Sunday. Today is 8th. 22nd Sunday, 12 noon, before 12 noon, because we are going to have the class on, we are not going to have the class next week. We are going to have the class on 22nd. So by 12 noon, send the, identifying the path, mark the path on this grid, and then submit your answer. That is your next assignment. Okay. Any questions? Just put this on a spreadsheet, identify the path, but just mention how you identify the path rather than just put in the path. Okay. You know the email address. It is gs5101@yahoo.com. We sent the, but put the title as put the subject line, put spatial statistics. Put spatial statistics in the subject line so that it will be delivered to the right folder. Okay? Any questions before we wind up the session? I'll give you time to write down this. Right? Any questions? No. Right. Okay. I'll give you 5 minutes to write down this, and then then you can leave the class. Okay? Thank you.